Hello, and welcome back to Math 100. This is section 2.2, which is on deceptive and misleading numbers involving percentages. All right, so in section 2.1, you learned the basics or the basic notions concerning percentages. And now we go on to discuss what could be deceptive, how people use percentages in sort of a deceptive ways or misleading ways. You have to be careful because percentages are very, very widely used. And depending on who is stating what, they can be stating something truthful, but quite misleading. All right, so I hope this will help you in your practical everyday life. Section 2.2, let's look at this as I share my screen. All right, section 2.2, the title of this section is Deceptive and Misleading Numbers, and mainly percentages. Here's the main question. How can percentages trick you? Okay, yes, people do trick you. People want you to believe what they want you to believe. And therefore, they will do all kinds of numerical percentage gymnastics to make things sound worse or better, depending on what it is that they want you to believe. All right. So as an intelligent citizen, you want to make correct assumptions. You want to be critical, and you want to be very careful when people state numbers, especially percentages. All right. So we go and we have different topics within this section, but we first talk about, and this is a review, but we talk about comparison. Okay. We already talked about this in the first section, but what is the absolute difference? The absolute difference is the numerical difference, right? It is numerical difference. It's simply A minus B. You know what? I'm going to use my handwriting. I think it's a little better when we write mathematics, right? So if you're talking about A and B, that's A minus B. Or B minus A, that depends on which is bigger. Now, the absolute difference doesn't have to be positive, but often we subtract the smaller one from the bigger one, so this number is positive. And I should mention here, when I say comparison, I am comparing quantity A with quantity B. Okay, so there are two numbers given. The absolute difference is just the difference between those two. But the relative difference is something not absolute, something more relative than that. And that just means it's the percentage difference. Okay, and so you divide the absolute difference by the what? By the base number. Now, what is the base number? That's the tricky part. Okay. And what makes the relative difference relative is exactly this portion or this part, okay? What is the base? Depending on which base you use, the relative difference will be different. Again, in section 1, we touched on this, but the base, the reference number is the quantity that you see preceded by a couple of keywords, right? What are those keywords? Of something or than something. Okay, these are very small words, prepositions, but what follows these words is the base of or reference number. Okay, the base of the percentage or the reference number. So here is an example. My watch costs $80 while my sister's watch costs $100. Okay, so what is the absolute difference? Well, absolute difference is easy. 100 minus 80 is equal to 20. And in this case, of course, unit is the dollars. And so $20, that would be the absolute difference between my watch and my sister's watch. But here comes the tricky part, right? What is the tricky part? Well, my watch is what percent cheaper than my sister's watch? Let's try to do this using, and again, I'm going to change to handwriting mode because that's much easier to write this. Okay, so $20, right? But you see, my watch is blank blank cheaper than my sister's. So my sister's watch price, which is $100, becomes a reference number. So then 20 divided by 100, that's 20. Well, that's 0.02, which is 20%. And so that is the answer to this question. My watch is 20% cheaper than my sister's because mine is 80 and hers is 100. This may have been easy. The next one is different. Hers cost what percent more than what follows the word then? Mine, or my watch, or my $80 watch. So for this one, you would have to divide the absolute value or the absolute difference of $20 by the price of my watch, which is $80. And the quotient is 0.25, which is 25%. And the answer, her watch costs $25 more than mine. And the reason this number is bigger than this number is because now the base number is cheaper. My watch is cheaper than hers, right? And so the price. And by the way, these two percentages will always be different in the relative comparison. Okay, so describing the change. Let's talk about describing changes. So this change is, of course, is something that takes place with reference to time, right? In regard to or with respect to time. So the old price or old value becomes not price. What used to be old now becomes that which is new. Okay, old and new. And so this is always going to be the base number describing a change. The absolute difference, let's go ahead and write this down. I hope you're taking notes. Okay, the absolute change is the new quantity minus the old quantity. That's simple. Okay, but the relative change is the absolute change divided by the old number. So this is the percentage, I guess you say the percentage change, and the base is always not the new or the current one, but the old quantity or the old value, right? So here's an example. Let's go ahead and work on this. The average gas price went from 360. Oops, sorry about that. 360 to $4 over the last month. Find the absolute and relative change. The absolute change is easy. Okay, that's $4 minus 360, and that's 40 cents. Okay, so that is called the absolute change. The relative change is taking that 40 cents and divide it by which one? Old, new, right? You always divide by the old number because the whole idea is the old is the reference. Okay, so in other words, this old changed to something. When you talk about the percentage change, of course, we are referencing the old number because that's where the new number is coming from, right? So this must serve as the standard or the reference or the base of the percentage change. So you do this 0.4 divided by 3.6, and you get the answer, which is 0.1111 repeating. We use this notation wavy equation, wavy equal sign, which is approximately equal to. And you see this all over the book, for instance, and this means the price of gas approximately increased by 11.1% over the last month. Okay, so that's how you can find the percentage. Make sure you use the old number as your reference for the percentage. So that is describing the change. Now we talked about describing or comparing two quantities and describing a change between one quantity and next. And now let's go to a percentage change followed by a percentage change. Okay, this is tricky, all right, because things do go up and down. Okay, so when those things happen, when that happens, how do you calculate the total percentage difference? All right, the price of a rental car increased by 30% 1 month, and then increased again by 40%. So how much was the increase total? Is that 30 plus 40, and is that going to be 70%? Well, it turns out if you actually calculate it, it's not quite the sum of the two percentages. In other words, the point is you can't add percentages precisely because the reference numbers are different. Okay, so if something increased by 30% 1 month, followed by another increase by 40%, what was the total percentage of increase? Right. So let's look at this. How do you solve a problem like this? Now in 1.5, we had problem solving strategies, right? Like, a person buying a horse or something. Okay. One way to address these problems very concretely is to start with a particular number. Let's say you start with 100. 100 is a nice number to use because it's easy to calculate the reference number, to calculate percentages. All right, so 30% up means now it's 130 because clearly 30% of 100 is $30. And if you add $30 to $100, you get $130. But now you have to calculate the 40% increase. 40% of 130 is what? So this is 0.4 times 130. And this happens to be 52. 52. So you add, 130 plus 52 is 182. Look, the price used to be $100. Now, after 2 weeks, it's 182. Clearly, the answer is 82% increase overall. Right? Not 70%. So you cannot just add these two percentages. You have to do some sort of a calculation like this in order to calculate the total increase in percentages. Okay, so actually it's 1.3 times 1.4, and that's how you can get 1.82. That will give you the 82% increase as an answer. What happens if you get a 50% pay cut one day? So you go into your work, your boss says, look, sorry, but I almost had to lay you off, and but I have been able to save your job, so you should be thankful to me. But the bad news is I'm going to have to cut your pay to half. And you say, well, thanks a lot for keeping my job. Well, you may be appreciative because you still get paid at least half of what you used to get. But then the following day, your boss says, look, I can raise your pay by 50%. So you're happy because you think minus 50 plus 50, that's 0 plus or minus 0, and you get your previous pay back, right? Not so fast. Why? Because 50% pay cut followed by a 50% pay raise is not equal to 0%. Let's see what happens. Let's say if you start with 100%, 50% cut means you only get $50 because 50% of 100 is $50, and that's how much your daily wages, daily income or the salary was cut, and so you have $50. Now, this time you have to calculate 50% of the new pay, maybe a daily pay, which is, $50, not 500. You wish. Not $5 either. Okay, so what's $50 of 50? That's 0.5 times 50, and that's 2.5. So you add 25 to 50, and you get $75. Look, you used to make $100 a day, now you make $75 a day. The difference is $25, which is 25% of your original pay, right? So you actually lost 25% of the of your daily wage if this is the case. So you shouldn't be happy that if you got 50% pay cut followed by 50% raise, you did not break even, right? And that's the tricky part of percentages. Because the reference numbers change, you cannot simply add or subtract percentages. I hope this is clear, right? Now, there are other ways in which percentage numbers can mislead or misguide you or deceive you. So let's look at the second part or the second page of these notes, or the notes for section 2.2 in the next video clip.